This video introduces the new features for ANSYS Mechanical 2020 R2. You can now specify licensing preferences in Mechanical using a new File tab option, License Options. This enables you to disconnect the license management from Workbench and organize the use of your licenses in Mechanical. To reduce disk storage requirements and improve performance, the Setup cell of the external data system has a new category in the Properties pane, Import Settings. Using the By Reference option of the file's import type property, the application references the external data file instead of transferring the file to the project folder. The new ACT extension, External Study Importer, simplifies the process of importing files from simulation applications such as Discovery and Autodesk Fusion 360 into Mechanical. You can now change the default values of the lighting properties applied to the model using new preferences available in the Options dialog. The animation process has changed. In the past, the application processed a result animation and then presented it. Now, animations display as they're being processed. In the previous release, this example would have taken 15 seconds for the animation to start. For line bodies and surface bodies, the model type property can now be used to specify reinforcements on individual bodies within your model to strengthen their structural integrity. Line bodies represent reinforcing fibers. Surface bodies represent a reinforcing layer that is either homogeneous or composed of a layer of evenly spaced fibers. In addition, you can scope results to your reinforcement bodies. You can now open the Electronic Computer-Aided Design (ECAD) file types ANSYS EDB, ODB++, and IPC 2581. Opening these files in Mechanical also displays the new ECAD Import pane that you use to view the details of your circuit board. Choosing not to display the details of complicated components using the Fidelity option speeds up processes such as mesh and solution. You can now use the commands APDL object for the distributed mass, point mass, and thermal point mass geometry objects. You can now run design point studies using different materials by parameterizing the assignment property of the body and part objects and the material name property of a material assignment object. For Abacus, Nastran bulk data, and LS-DYNA input file types, whose master file contains an include command that references supporting files, the application will automatically add files to your system. Mechanical now automatically creates additional solid shell connection elements for improved solution accuracy for contact conditions between the edge of a surface body and the face of a solid body. The new Solver Controls property, Quasi-Static Solution, helps improve convergence for analyses that are experiencing difficulties achieving convergence. Using the new Loaded Area property available for pressure and imported pressure loads, you can specify whether to include surface deformations as they occur and change the surface area during pressure load application. Now, using the external data system, you can import temperature loads for certain analysis types as well as body temperature loads for modal analyses. You can now apply pressure, hydrostatic pressure, and force loads directly onto 3D shell or 2D plane element faces without creating surface elements via the direct option of the Applied By property. Imported pressure can also be applied directly to solid shell element faces or face corner nodes using the direct option of the Applied By property. Now, when performing either a thermal stress or submodeling analysis, you can import and map load data into your analysis by directly referencing a mechanical APDL result file, .rst or .rth, that you created during a separate analysis. This is supported for certain analysis types only. For the boundary conditions, displacement, remote displacement, and nodal displacement, a new property, reverse direction for inverse steps, enables you to specify that certain steps in an inverse analysis are reversed in the direction of the specified displacement. The nonlinear adaptive region condition now supports the use of the boundary conditions remote force, remote displacement, and moment, as well as the use of remote points. You can now specify force convergence and tangential fluid pressure as outputs during the solution for a contact result tracker. For the solution information object, the new option, maximum residual force, of the solution output property now enables you to display the maximum value of the residual forces for each cumulative iteration of the solution. Using new fields of the advanced properties for the Solve Process Settings dialog, additional files to upload or download, you can specify files to upload or download from the remote machine during a remote solution. You can now use the convergence object when your analysis includes imported loading conditions. Reaction probes now support the use of the missing mass and the rigid response effect properties for RS base excitations. You can now scope the mass, volume, center of gravity, and moment of inertia constraints to body-based only geometry or named selections. In addition, there's another new scoping option, all optimization regions. This option applies the constraint to all optimization regions. A new structural optimization method is now available, parameter-free morphing. This new option of the optimization type property enables shape optimization using mesh node relocations. Using this method, the application computes an optimal shape in the design domain that you can apply to a selected region of your model and that also includes specific design objectives and constraints. For additive manufacturing simulations, you can now create a voxel mesh on the part as well as on STL supports so that connections between the two are inherent in the conformal mesh. Voxel meshing the part and insertion of STL supports are both now included in the additive wizard. In a rigid dynamics analysis, you can now have friction in spherical, slot, universal, general, and imperfect, in-plane radial gap, spherical gap, and radial gap joints. The Workbench LS-DYNA system has been renamed LS-DYNA and is now available in the Analysis Systems section of the toolbox in Workbench and can also be inserted into Mechanical from the ribbon. The LS-DYNA and explicit dynamics systems coexisting within the ANSYS Mechanical environment give users unparalleled choice and flexibility in performing highly nonlinear analyses. You can now use the smoothed particle hydrodynamics, or SPH, method in both LS-DYNA and explicit dynamic systems. The meshless method provides an alternative to the Eulerian or ALE approaches to model highly deforming regions. A new meshing method called particle has been created, which will generate a uniform cloud of particles within a body. The cloud of particles serves as the interpolation points for the SPH method. In explicit dynamic systems, a new boundary, called limit boundary, has been added to impose restrictions on the displacements of SPH particles in the global coordinate system. The LS-DYNA solver provides a number of SPH approximation methods to avoid issues like tensile instability or to deal with fluid-like materials.